This is a good example of expected value. And we've got a raffle ticket problem. So the raffle ticket problem is defined this way, that 500 tickets are sold and they cost $3. And there's a prize of $400 to be awarded, and that's the only prize. So it looks like there's two possibilities. You could either win $400 or you could lose. There's, out of the 500 tickets, there's only one winner. So one in 500 will win, and that means that 499 of the 500 are going to lose. Here's the catch. We read here that if you win, well, really whether you win or lose, you don't have your ticket costs, the $3, refunded. So what you have to notice here is that when you win $400, your gain is actually 400 minus that 3, or $397. Your gain when you win $400 is the 400 minus the $3 ticket fee. So that's going to come to $397. If you lose, then your loss is going to be the cost of that ticket. So if you don't win anything, you've paid $3. I like to use this chart to organize the information. I feel like it puts it in a nice, easy format to then plug into this expected value formula. The expected value is the probability of an outcome, 1 in 500 will win, times the gain of $397. And we do this for each possible outcome. In this case, there are two outcomes, winning and losing. And if you multiply these probabilities times their gain or loss and add them together, notice that the formula has you add them together, you will be able to calculate the expected value. Now, once you have the expected value, notice that to find the fair price, fair price means the price where everyone breaks even. So if everyone breaks even, that means that the expected value is going to be 0. A formula you can use, if there is a price, a cost, then breaking even is going to need to include getting your money back. So the fair price is going to be the cost plus the expected value. Once you have the expected value, we can add the expected value to the -3, and that'll give us the fair price. I hope that that helps with this problem. And let's go to one more that's similar. And here we have a spinner. So what we will do with this one is the wheel pictured on the right is spun. Assume that a person spins and the pointer's awarded the amount indicated by the pointer. If it costs $5 to play, determine the expectation of a person who plays and the fair game. So if you play, it looks like there's two possible outcomes. You can spin a $4, the red, or you can spin and it'll land on $12, the blue. So we could describe these as red and blue, or describe them by the amounts, however you want. But the loss, when it lands on $4, you're going to lose $1, right? Because it costs $5 and then they give you back $4. So it looks like you have paid $1. Maybe it would make a little more sense to say we have a -5. Let me write it this way. Cost is like a -5, and we add that to our +4 because it's like a win, a gain. But this is going to come to a loss of $1. When the spinner lands on $12, we've paid 5 and we are given 12. So it looks like we come out ahead, so a +$7. The probability is half and half for each of these. So let me show you a shortcut in the calculation. Using the formula to its fullest, showing every part, it'd be the probability times the loss plus the probability times the gain. But do you see that this is going to be the same thing as 1/2 because it's equally likely. There's two outcomes that are both equally likely. So we could put each of those outcomes here and find the sum. And it's going to be the same thing because when we do the arithmetic here, we end up doing -1 plus 7/2. So it's the same thing as if I did 1/2 of 6. But either way, you'll be able to get the expected value. And then to get the fair price, remember the fair price is that price where everyone breaks even. So in other words, fair price is when the expected value comes out to 0. And the formula that we can use is fair price is equivalent to the cost plus the expected value. So once you have the expected value, and we know that the cost is $5, when we add those, we'd be able to get the fair price. I hope that this video helps with those examples and others like it. Keep practicing and let me know if you have a question about a specific aspect of these problems.